forensic triage evidence using MFT, that is nothing but Master File Table. And so, carrying on from the previous demonstration, we are going to take a look at the second part of triage evidence using MFT, Master File Table with FTK Imager. So let's get straight back into the demonstration. Okay, so for the second part of this demonstration, we are going to add the evidence item of the full image which we took from the suspect machine, that is E01 file, in the previous demonstration, right? When I open this up and add into the evidence tree, I can see the suspect PC all of the partitions which were gathered at the time of the acquisition. When I take a look at this, there should be no surprise in the fact that this is partitioned with NTFS, that is New Technology File System, as I would probably expect with a Windows machine. So before starting, let's check all the folders and files. If we compare this with our custom content image from the previous demonstration, where we were only looking at JPEG images from a user called Dolly, and I can now see all of the built-in and specific users within this machine. I would then be able to take a look at all of the users within the environment, and of course all of the folders and all the files allocated to them. I am also able to see all of the system files which have been generated on this machine. Now, depending upon the level of investigation will depend upon how useful a lot of this material will be. But in general terms, the majority of this is going to be of little use to us when we are conducting normal kind of investigation. However, we are now able to search forensically across this machine rather than doing a quick triage as we did previously. As we are going to take a look at the second part of triage evidence using MFT with FTK Imager. So what is this MFT? What is this Master File Table? Let's understand this a little bit. The MFT is a database of every file which is held within NTFS, and act as a fantastic reference point for us should we need to conduct searching across this whole image. It gives very comprehensive information about the files, and of course that also includes my suspect files that we may be interested in. We can go through the whole extensive folder and file selection and look for particular files and folders of interest. So this is about the MFT file. Now, for this demonstration, we need to find the MFT file. Now, how to do that? How to find the MFT file in the suspect drive? So simply, if I select the NTFS partition, inside the root, I need to search the MFT file. You can see that the MFT file or the master file table is then scanned and populated within the tool. If I left select the root folder at the top of the tree, you will then be able to scroll through until you find the MFT file, which is indicated by a MFT, that is with $symbol and MFT. This then allow me to come down into the previous pane, and if I am right select, I can then use the find function or Ctrl+F in order to start finding and looking for different files and attributes across the whole system. So if I was interested in a particular file, for example, let's check for info.png. I could simply search on that to see its record within the MFT. Once a file has been located within the MFT, I can then start to take a look at some of the properties which are available to me, both from the hex and the conversion of the hex into property values. In order to do this, the first step would be to find the record holder or the magic marker of the file in question. The magic marker could be used as a generic term to refer to a tool or feature within FTK that is used to mark or flag items of interest within the evidence being analyzed. And this is found by locating the file 0 reference, which you can see indicated at the top. Once you have located the magic marker at the file 0 record, then you can use the offset to take you through the hex to find things such as creation time of the file change time, and the file read time. To do this, you need to find the hex reference, which can then be converted over into the properties pane. So to go to the offset by doing right click on the viewer pane or simply press Ctrl+G, which allow you to then select the offset, which is 80, and keep decimal selected and ensure that you are in the current position. If you select the beginning of the file, it will search from starting. Similarly, if you select end of the file, it will search from the end, from the bottom. Hence, ensure that you are in the current position and selecting the current position. It will take you to the location where the vertical bar is present. Let me redo it so that you people can find the difference. Please have a look at the highlighted section. Once I click OK, the vertical bar will appear on the highlighted section. I hope it is clear now. So this is the creation time of the file, where the vertical bar is present. Now select the line of hex or the 8 bytes, which then refers to the creation time of the file. Now in order to view this point, I need to come over to my combination pane and take a look at the hex value interpreter. You can see here that the file time has been given to me by date and time. Next, coming to the alternate time of the file, ATF. If I were to come across the next 8 bytes, it will then give me the alternate file time. Next, file change time of the file, that means FCT. And indeed, if I come to the next line, it will give me the file change time, and so on forth. And I can continue to select this entries, which will give me relevant times as we go through. Now the last part, file read time, that is FRT. This is the file read time that we are looking at, and once again it gives me the date and time, and this time it is an readable text rather than using hex. So to make you people understand and remember it better, let me add the box and highlight it. Okay. There are numerous entries, of course, that you can use by going through the MFT and taking a look at the values of each file. But remember that this is not the file itself. This is the MFT record that you are searching through. Now from this, how to recover data. Another great aspect of FTK Imager allows you to recover deleted or partially deleted files from the actual image. Remember that even when a user deletes something, unless it is been overwritten, you would still be able to gain access to it, and this also includes potential residues which is left in slack space. I'll try to show you demonstration of overwritten data, how it works. So one of the MFT attributes is the $data section. It starts with the code 0 into 80 and 000000, total 8 digits. Let's go back to the magic marker file 0, and by doing right click on the viewer pane or simply press Ctrl+F, which allow you to do a binary hex search for 80000000. This will point directly to the data section of the specific MFT record. Okay, let's click on find. So this part is little bit of mathematics, little bit of calculation, so I suggest you people to focus completely on this particular part. If you understood this part, then believe me, you can crack any case wherever FTK Imager is applicable. Obviously it will not do the advanced level of investigation, but if the open source tool, if we master this, then we can automatically take our investigation skills to the next level, and even we can learn the paid tools as well. So just focus on this particular part as it is important. Okay, the 4 bytes behind 0 into 80, I'll not repeat remaining 00, so please consider that. Okay, why? Because it will create confusion. So obviously it will have 8 digits, so starting number I'll just say as what it is. Okay, notice the length of the data section is 0 into 4800, which shows the length of the data section. When you highlight this 0 into 48, have a look at the hex value interpreter that is near the bottom left corner. We can see that the hex value interpreter converts this 0 into 48 to 72 decimals. Okay, now based on this, how we will find whether the file has been deleted or not. Okay, so to find whether the file is deleted or not, follow the steps. The code right next to 0 into 48 is 0 into 01. So now what this 01 is representing, what we have to consider by looking at this 01. So to make it simple, let's divide it into files and folders. Okay, obviously we will have the files and next is folders. So let's divide into two things. If in place of 01, if we get the values like 0000 and then 03 and 04, then it will be stated as follows for the files section and for the folders sections. Okay, so the first thing, files part, the file section, the 01 means the file exists, means it is an existing file. If it represents 0000, that means the file is deleted, means deleted file. Similarly, the same thing applies to the folder section. If it represents 03, that means existing folder. Okay, the folder is present. If it is 04, that means the folder is deleted, means deleted folder. As the code right next to 0 into 48 now at present for this investigation is 01. So please answer what it is. I'll give you 10 seconds of time. Good. And I believe many of you have got the answer that the file exists, means the file is present in the image. Then the pictures to be recovered have not been deleted from the hard drive. Information about the actual location of the picture on the hard drive is available in data runs, which start at byte offset 32 of the data section. In this case, byte offset 32 of the data section is 0 into 40. So what is this 32 of the data section? How we got this number 32, that is 32? Let's understand it. Have you guys remembered that we searched MFT attributes on the data section, it starts with code 0 into 80000000, 8 digits, right? And if we see at the right hand side of the viewer pane, the 4 dots before H are also highlighted along with 80, right? So we need to consider those 4 dots from there to the symbol which we have as @. I hope you guys can see this, right? And then the 4 bytes behind 0 into 80, we notice the length of the data section is 0 into 48. Now this 80000000 plus 48000000. So the 80 section have 4 digits, right? Consider 4 things, okay? And plus 48 also have the same 4. That means if we add both the things, we will get 8 bytes of offset. Okay, 4 plus 4, 8. And next, in the deleted or not section, the code right next to 48 is 0 into 01, where we find that the file is present, the file exists. So that's 01. Remember, right? That's 01. Now this 01 till 0300 has 8 bytes offset. So 80 plus 48, we have 8 bytes, and then 01 till 03 we have 8 bytes. So 8 plus 8, 16. Okay, now we have identified 16 bytes offset. And remaining 16 bytes, we need to consider the whole line of 01 00 00 00 03 00. Next to that, hyphen 0000, right? And next 05000. Now it is 16 bytes offset. As we are considering from those 4 dots there to the symbol @, if we count 16 plus 16 is equal to 32 bytes offset. That's how we got the number 32. Understood? So for your reference, I will again make the columns sections and I'll put a box and highlight it so that you can understand. Okay. In this case, next to the byte offset 32 of the data section is 0 into 40. Please have a look at the highlighted section near the left side corner of the property pane. Once I select 40, the hex value interpreter converts this to how much? Yes, right, 64 decimal. I hope it is clear now. As the hex value interpreter converted this to 64 decimals, now go to byte offset 64 from the beginning of the data section, where you will find the data run with information about the first cluster of the picture data. Many times the data run starts with 0 into 31 and ends with 0 into 0. But this is not always the case. In this case, the data run starts with 0 into 31. The code next to 0 into 31, in this case it is 0 into 6, which shows the number of clusters belonging to the pictured data. That is, once I highlight the 06, the hex value interpreter converts this to 6 decimals. Okay. This means the data of the picture fills 6 clusters. Next to 06, the next 3 bytes, that is 0 into 10 D0 0C, shows the number of the cluster. The hex value interpreter converts this to 8,39,696 decimals. So let me note down this in a notepad. Okay, I'll forget this numbers and all. So let me note down. and the decimal is equal to 6 clusters. Next, 3 bytes 0 into 10 D00C, which is 8,39,696 decimals. Which means number of clusters. Okay, now get back to FTK and click on the volume name in the evidence tree pane and the properties tab next to the hex value interpreter, which shows the size of one cluster is about 4096 bytes. Let me note down this too in a notepad as cluster size. That is 4096 bytes. So let me do some simple mathematics. Multiply cluster into cluster size. Okay, we need to multiply the cluster with cluster size. That is 6 into 4096. Okay, let me open the calculator so that we will not miss any number. Okay, so 6 is multiplied by 4096, which is around 24,576. Now you know the starting cluster is 8,39,696. And the size of the photo is 24,576 bytes. Forget everything. I just want you people to remember the starting cluster, that is 8,39,696, and the size of the photo is 24,576. Okay. For the reference, I'll pin both the numbers on the screen until we complete this calculation. Okay, so you'll come to know where this starting cluster is used and the size of the photo will be used. Okay, now click the volume name in the evidence tree pane and right click the viewer pane. Now select go to sector or cluster and enter the starting cluster number. What is the starting cluster number? Please remember. Okay, I hope you guys have remembered. That is nothing but 8,39,696, as we are already displayed on the screen. That is it. We have to enter in the cluster search box and then just hit OK. It will take you to the location where the vertical bar is present. Please have a look at the highlighted section. The vertical bar appeared in the highlighted section. I hope you people can able to see. Once we highlight the section where the vertical bar is present, the file header of a PNG file appears in the viewer pane. So we come to know that we have the PNG file. Okay. Now right click the viewer pane and select set selection length. And enter 24,576. What is this 24,576? That is nothing but the size of the photo. Yes, which is nothing but the size of the photo. I hope you guys have remembered this. It is also displaying on the screen. Now right click the selected data and click on Save Selection. In order to save this picture data as a file, I'll add it to my desktop so that we can gain access to it quickly. And also I can show you live. Let me save it without any extension so that we can have a look at whether FTK itself provides the original extension of the file as we save it, or whether we have to add the extension while saving it. In some cases, the application may automatically add a default extension to the file, such as .txt. For a plain text file, this is common in application like Notepad on Windows. If just you enter the file name and if you don't add the extension .txt, it will automatically add that txt extension if you don't specify. Okay, as we can see, we managed to save the file without an extension, which causes issues when I try to open or use the file. Many operating systems and applications rely on file extensions to determine the file type and how to handle it without an extension. The system may not know what kind of file it is and may not be able to open it correctly. Okay, so let me add .png extension and save the file. Good. Now I can access the file. It is generally a good practice to include an appropriate file extension when saving files to avoid potential issues. So as a bonus, file extensions are important, right? Because they provide information about the type of the file and the application that should be used to open or handle the file. So as a bonus to this course, I'll try to add a section on how to identify file systems when we are not sure about it. This is of course maybe very useful to you when you are conducting your investigations. So that's it for now. Okay, thank you.